Hello, and welcome to video 2 of risk management. In this video, we're going to look at what a hazard is, what hazards are derived from, and practice identifying hazards. First, we're going to identify what exactly we mean by a hazard. We define a hazard as a source of potential harm, and an unwanted event as a potential situation where a hazard can be released to cause this harm. Hazards are generally linked to a source of energy. That source of energy, when released, can cause harm. There's lots of different sources of energy you're probably familiar with. Things like gravitational potential energy, electrical energy, chemical energy, the energy associated with having something pressurized, with heat, with moving parts, and those energies can then manifest as hazards, as shown in the table on this slide. So, let's practice matching type of energy with the associated hazard. So here we've got 4 types of energy: gravity, noise, chemical, and radiant energy. And we have 4 images of situations where a hazard is present. So I invite you to pause the video for a moment and try and match the 4 types of energy with the 4 situations. And we're back. So, here are the matches. Take a moment, compare with what you matched yourself, hopefully, a moment ago. So, chemical energy associated with this chemical storage tank. Radiant energy is associated with fire. Gravitational potential energy associated with things falling down hills, in particular big pieces of machinery in this example. And of course, noise energy, which you can't really see, but we've represented here with a worker using their personal protective equipment to protect their ears. So let's look at a few more types of energy and situations where they are present. So we've got body mechanics, electrical, pressure, thermal, and mechanical energy. And then we have images related to these. So take a moment and match the energy with the hazardous situation. And we're back. So let's see how you did. See here, body mechanics energy can be hazardous when associated with employees moving things around inside a work site. We have electrical lines as an obvious source of electrical energy that can be hazardous. We have pressurized gas cylinders, thus the energy is stored in the pressure of the materials. We have fires, which, in addition to the radiant energy we discussed in the previous example, also have thermal energy associated with them. We have moving pieces of machinery, where that kinetic energy of motion can be a hazard. Let's look at another example. So we have these large dump trucks that are used in large-scale mining operations. They can move up to 50 kilometers an hour. So even when they're empty, you can imagine that there's quite a lot of momentum associated with something of this size. They're hard to stop. They're hard to precisely maneuver. And we look specifically at the dump truck in this picture in the lower right corner. you can actually see the operator's cabin. This is the right side of the photo, so that's the left side of the truck. And visibility is a major issue with this particular design. The operator can see to their left and straight ahead, but it's hard for them to see down, it's hard for them to see to their right, it's hard for them to see what's behind them. So visibility is a major concern when you have this sort of vehicle. Now consider one of these vehicles on a work site. There are a lot of hazards when you can't see the details of where your vehicle is located. So collisions are actually a major concern. Just looking at this relatively mundane scenario here, we can say, well, there's a hazard of collision between the two large trucks, the hazard of collision between either of the large trucks and the orange digging machine in the back of the photo. There's a hazard of collision between either of the large trucks and the white flatbed truck on the right of the photo. And there's a hazard of collision between the orange digging machine and the white flatbed truck. So not being able to see takes an already challenging situation and makes it more so. And unfortunately, in this particular instance, that lack of visibility caused a major problem. If you look closely at the picture, you can actually see that crushed under the wheels of truck 1 is a small pickup truck. The operator of truck 1 was focused on seeing truck 2 to his left and didn't realize that there was a small pickup truck in front of him until he'd driven over it. So once again, visibility plus all the other distractions and concerns on a work site can lead to very real problems. So once we've identified a hazard, what do you do? Clearly the most preferable option for what to do when you identify a hazard is to eliminate it. And we've kind of got that illustrated here on this slide. The most effective to least effective way to deal with hazards, with elimination being our most effective means of eliminating a hazard. If you can't eliminate, then you want to try and substitute a greater hazard with a lesser hazard. And if you can't do that, then you're going to have to develop some engineering controls. And if engineering controls still can't completely mitigate your hazard, move on to administrative controls, which are regulations and rules about how things are to be done. And finally, you need to give your workers personal protective equipment to protect them from hazards. But typically that's going to be the least effective way to deal with a hazard. So you want to start out at the top of this chart and work your way down whenever you're looking at mitigating a hazard. So just to give you some examples, you can eliminate a hazard by, for instance, putting a mat or other covering to prevent people from tripping on an uneven element of the floor or loose cables, things like that. Substitution. You can change materials, perhaps using a non-flammable oil in a situation where the high temperatures are concerned. And then your next option for dealing with hazards are administrative controls. So these are rules, written policies that describe situations that employees should not engage in to avoid hazards. For instance, in a chemical plant with volatile chemicals, you prohibit the employees from smoking because the heat from the cigarettes could ignite the materials. And finally, you want to mitigate hazards by protecting employees with personal protective equipment. But as I mentioned a moment ago, people can forget to put on their safety glasses or not be wearing their nitrile gloves when they should be. So clearly this is a less comprehensive way to mitigate against hazards, and we're going to want to exhaust these prior options before we come up against having personal protective equipment as the only line of defense between an employee and a hazard. So, this is the end of video 2. I hope you can now define what a hazard is, recognize sources of energy and how those can become and contribute to hazards, and have an understanding of the different ways that we're going to mitigate the risk associated with hazards. You may now proceed to quiz 2.